Welcome back for part 2 of Unit 9's review. So we will be going over problem 28, which is a rhombus problem. And 28 through 31 has to do with the same rhombus. So what I'm going to do is just do 28 and then have you do 29, 30, and 31 on your own. So it's a rhombus with two diagonals and an intersection point at E. It says this rhombus has side or segment EB is 9 units, AB is 12, and the measurement of angle ABD equals 55. It says find the measurement of each, it says find each measure. So for 28, it wants us to find segment AE. So let's just fill in the blanks of what we know. We know that EB right here, this little segment of the diagonal is 9. AB is 12. And I want a measurement ABD. So this little portion right here is equal to 55. And it wants to know AE. So it wants to know this portion right here. We'll just label that as X. Well, diagonals and their segments in a rhombus are congruent. So that means that each of these little segments of the diagonal are congruent. And since AE is going to equal segment BE, we know that AE is going to equal 9 because BE is equal to 9. And all of these little segments of the diagonal are congruent. So I want you to finish number 30, 29, and 31. They have to do with this figure. And now we are going to get into problem 35. Actually, we'll skip 35. It's a very important topic, but pay attention to the video of the guided practice that I did for the rhombus section or for lesson 4. It wants you to determine if the quadrilateral is a rhombus, rectangle, or square. So please go back and watch that video and practice that on your own. We are going to move forward to the next problem, which is 35 on page 852. So we have a kite. That's F, G, J, and H, and it has a segment right there of 12 and 15, and it says find GH. So when we look at GH, it's going to be this little section of the triangle right there. And we know the diagonals in a kite are perpendicular and they form a 90-degree angle. So we have a triangle that's formed, a right triangle, and this is going to be G and H. We're going to label that as X, and it's 15 and 12. So X would be the hypotenuse. It's the longest side of this triangle. So we're going to use the Pythagorean theorem that says a squared plus b squared equals c squared. All right. And our A is going to be either of these legs, and then B would be the other leg, and C is going to be the hypotenuse. So that means that we're going to have 12 squared plus 15 squared equals c squared, or in this case, we labeled c as x squared. So it's 144 plus 225 equals x squared. Doing the math, I just want to get my calculator to be able to take the square root of 369. But I think that would be the square root of, I believe, 17. Nope. It is 19, sorry. Square root of 369 is approximately 19.21. So that would be our solution for the length of GH. Okay, so now we're going to move on to the next type of problem, which problem 36 is similar to 35 because it has you find the measure. Essentially, it's a isosceles trapezoid, kind of like what we did in the very first question. So do 36 on your own, and then we're going to go on to number 7, which is the next type of problem. All right. So number 7, right here we have a kite. It says that C, D, F, G is a kite. It's 67 degrees at C, 49 degrees at F. And those two sides, CD and CG, are congruent, and DF and GF are congruent. And it says find the measurement of angle D. So it's this measurement. So I'm going to label that as X. We don't know what it is. However, we know that in a kite, there is a property that we discussed from the last lesson that states that at least one opposite sides in a kite are congruent. So let me repeat that again. A kite has one pair of opposite sides that are congruent. So since F and C do not equal each other and they are opposite, we know that D would be congruent to G. We also know that any quadrilateral, it doesn't matter if it's a trapezoid or a parallelogram, a kite, or a rhombus, we know that all of the angles added together equal 360 degrees. So we can label angle G as X as well because it's equal to angle D. So angle D is congruent to angle G. And we know that we're going to add up all of the angles. So we're going to go X plus 67 plus 49 equals 360 degrees. That's basically, we're adding up all the angles again in the kite and setting it equal to 360 degrees. So we have X plus X. We're going to combine like terms. 67 plus 49 is 116. And then we have it equal to 360. So now our next step, we're going to take 116 and subtract it to both sides. So 360 minus 116, and that's 244. So we have 2x equals 244. We're going to divide by 2, and x is going to equal 122 degrees. So that means that the measurement of angle D is 122 degrees, and the measurement of angle G is 122 degrees. And when we add them all up together, you can verify your answer because it's going to add up to 360. All right, so that is problem number 7. And now we are going to move on. and I want to look at the rhombus for problem 8, 9, and 10. And essentially, when we look at this, they all have to do with the same type of problem. 8, 9, and 10 have to do with the rhombus diagram that I'm about to draw. So I'm only going to do problem 8 and let you work on 9 and 10 since it's the same diagram and the same type of problem. So we have this rhombus right here, M, N, O, and P, and we have diagonals, and the intersection of the diagonals is R. So problem 8, it says that it's a rhombus. So the measurement it wants to find of M, R, N. So let's draw that. The measurement of M, R, N. So it's right here. It wants that angle. Okay, so a rhombus, we know based on its property, has diagonal lengths, the segments that are all congruent. And it also has congruent side lengths. So the thing is, what we could do is we know that a circle completes 360 degrees, okay? But essentially a rhombus, this angle, every single angle right here is going to form a right angle, and I'll explain why. If we took the angle of this whole entire four angles right here, they're going to add up to 360. So a rhombus, if we want to find one of these little sections, is going to be 360 divided by 4, which is 90 degrees. And that's why I drew a right angle, because all of these angles are going to be 90 degrees. So I want you to work on 9 and 10 on your own. And then number 18 and 19 are basically the same type of problem that we've done previously. They want you to look at these shapes and determine if the quadrilateral is a parallelogram. And so I'm going to do number 18, and I'll let you do number 19 on your own. But number 18 has a drawing, just like number 19, of a parallelogram or a quadrilateral, and it's asking, based upon the congruency statements, if this quadrilateral is a parallelogram. And what we're going to do is I'm going to immediately tell you, yes, that this parallelogram is a quadrilateral. And the book wants you to look at the test for parallelograms, which is on, for both 18 and 19, which is on page 813 of your book, or section 13.2. There is a theorem. It's theorem 13.8. So theorem 13.8 in your textbook basically says that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So yes, this quadrilateral is a parallelogram. And I wrote the theorem down, and if you want to explain it in more detail, if I see the theorem, then that's good, but I kind of want you to say, just kind of write the reasons why this is a quadrilateral, this quadrilateral is a parallelogram. Just say opposite angles are congruent, and that will